Welcome to Boffin's Academy. Today we're going to do IB Maths, specifically Analysis and Approaches Standard Level.
How to find the monotony of a function and how to find the maximum and minimum of a function. So therefore, if we were to put the title on the lesson, how to find the minimum and the maximum, if there is one, function along with the intervals of monotony. In order to do that, we're gonna need to give a specific example. We're not gonna give something very difficult. To be honest, we're gonna give a simple example, just a simple parabola. I assume that since we're dealing with a high school topic, year 10, year 11 topic, I assume that everyone is aware of the parabola equation, of the parabola function. This is a very typical example. F of x is equal to x squared. As it can be visibly seen, we have a minimum, which is a total minimum at x coordinate equal to 0, and the minimum is equal to 0. So, how are we going to find this minimum algebraically? Because there are two ways to find the maximum and the minimum of a function. Two ways to find them. Let's write that. Two ways to find maximum and minimum. The first one is to solve the problem graphically. So if you have the graph of the function, it's going to be very easy since it will be visible. The points at which we have maximum and a minimum will be visible, therefore you can relate to the graph and you can tell that as it is evidently seen at the graph, we have a minimum at x coordinate equal to 0 and the y coordinate is equal to 0 as well. But the first way, the second way to do that is algebraically. First way, if you are given the graph, you can just mention the graph. But the second way is algebraically. We're going to use derivative functions. We're going to use the very known derivative function of f of x algebraically by using derivative. How do we do that? First of all, you need to be aware, every student needs to be aware with the rules of differentiation. So I'm going to remind you that when we have a function, a polynomial function of the form f of x is equal to x to the power of n, and n is a positive integer and not equal to 1 or 0, positive integer, then the derivative function of x to the power of n is equal to x to the power of n inside parentheses, outside you put a prime, this is n times x to the power of n minus 1. So, what is the derivative of x squared? The derivative of x squared is equal to 2x. Why? Because n is equal to 2, you get to put 2 in front of the x, like this. It goes in the front and the exponent is reduced by 1 unit. So you have 2x. Now you do what? In order to find the maximum or the minimum, you need to remember that in the points that we have a maximum or a minimum, we have horizontal tangent lines. If you have an horizontal tangent line, this means that at this spot, the derivative at this spot, at this coordinate is equal to 0. So therefore, we solve the equation. F prime of x, f derivative of x is equal to 0. This means that 2x is equal to 0. Divide both sides by 2. This means that x is equal to 0. Now, we are going to make a sign table in order to find the intervals of monotony, the decreasing and the increasing function, where we have an increasing function, where we have a decreasing function, along with the points of maximum or minimum. So, we need to draw 3 lines, horizontal ones. We need one for x, from negative infinity to positive infinity. Here we have the number 0, f prime of x, and here we put f of x. Gonna have to draw a vertical line here. As we have already proven, f prime of 0 is equal to 0. Below this number f prime is negative. Above this number f prime is positive. So basically when you have a negative first derivative, this means that the original, the mother function is decreasing, and when we have a positive derivative, the function is increasing. Therefore, here we have a total minimum. Hence, we proved what we have graphically shown already. This was a small preview of how I operate in the classroom. We create PDF files with those screenshots, and a student can have them on their mobile phone or their tablet or their laptop or anything else. That's all. Have a nice day.